Space exploration is a pursuit that embodies humanity's deepest curiosities, dreams, and ambition. Over the past century, we have embarked on some of the most daring and awe-inspiring missions in the history of science, sending spacecraft into the far reaches of our solar system and beyond. Among the most extraordinary tales of perseverance and achievement in space exploration are those of NASA's Voyager spacecraft, Voyager 1 and Voyager 2. Launched in 1977, these two probes have defied expectations and continue to provide us with groundbreaking scientific discoveries, even as they venture far beyond our solar system into interstellar space. These spacecraft, which were initially designed for short-term missions to study the outer planets, have become the longest operating human-made objects in space, providing invaluable insights into the mysteries of our cosmic neighborhood. Their ability to survive for over 4 decades, continuing to send data back to Earth despite being billions of kilometers from home, makes them a true testament to the resilience of human technology and the unyielding desire to explore the unknown. When Voyager 1 and Voyager 2 were launched, the expectations for their longevity were relatively modest. In fact, NASA engineers and scientists did not expect them to last much longer than a few years at most. Their original mission was to explore the outer planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, planets that had never been studied up close. These planets were vast and distant, each with its own unique features, moons, and ring systems that scientists were eager to examine. But the space probes had an even grander fate in store. Voyager 2 was the first to launch, on August 20, 1977, followed by Voyager 1 just 16 days later. These two spacecraft were initially designed to perform flybys of Jupiter and Saturn, gathering data about their atmospheres, moons, and ring systems, and then continue on their journeys to explore other outer planets in the solar system. However, by the time the first data started coming back to Earth, it was clear that Voyager 2 would be able to achieve more than just the original mission, with the spacecraft continuing on its path, exploring Uranus and Neptune along the way, each encounter yielding new and surprising discoveries. The early days of the Voyager program were filled with excitement and uncertainty. As soon as Voyager 2 was launched, the spacecraft ran into some early communication issues that threatened to derail the mission before it even began. Thankfully, NASA's engineers were able to work quickly to resolve these problems, and the spacecraft was back on track. Voyager 2's flybys of Jupiter and Saturn were immensely successful, as they provided some of the first high-resolution images of these giant planets, revealing intricate details of their cloud systems, ring structures, and numerous moons. The probe made groundbreaking discoveries, such as the discovery of the Great Red Spot on Jupiter's surface and Saturn's moon Titan, which would later become one of the most studied moons in the solar system. Voyager 2's instruments also made crucial measurements of the gas giants' atmospheres, providing new insights into their composition, weather systems, and magnetic fields. These observations helped scientists understand more about the outer solar system and the gas giant planets, forming the basis for decades of planetary research. But what made Voyager 2's journey even more remarkable was the way in which the spacecraft continued its mission far beyond its expected lifespan. As it passed Saturn, Voyager 2 was given an extended mission to continue its journey toward the ice giants Uranus and Neptune, two planets that were still shrouded in mystery. No spacecraft had ever come close to these distant worlds, and there was little information about their moons, magnetic fields, or atmospheres. Yet Voyager 2's instruments would soon reveal surprises that no one had anticipated. When Voyager 2 reached Uranus in 1986, it made a historic flyby, capturing the first detailed images of the planet and discovering new moons that had previously gone unnoticed. It also revealed Uranus to be an extraordinarily tilted world, with a rotational axis that is almost completely horizontal to the plane of the solar system. This discovery challenged previous ideas about the formation and behavior of planets and would remain one of the most fascinating aspects of Uranus for years to come. Just 3 years later, Voyager 2 reached Neptune, the most distant planet in the solar system. As it passed the planet, the spacecraft discovered that Neptune's largest moon, Triton, was far more active than scientists had predicted. Voyager 2 captured images of geysers erupting from Triton's icy surface, revealing the presence of volatile materials beneath the frozen exterior. These geysers were unlike anything observed on other moons in the solar system and suggested that Triton had a complex internal structure. Voyager 2 also observed Neptune's rings and its strange blue atmosphere, further expanding our understanding of the planet's dynamic environment. In fact, the data returned by Voyager 2 during its flyby of Neptune were so valuable that they contributed significantly to our understanding of the planet, which had previously been an enigma. At the same time, Voyager 1 was also on a unique journey of discovery. Launched just 16 days after Voyager 2, Voyager 1 took a slightly different trajectory that allowed it to reach the outer reaches of the solar system ahead of its twin. By the time it passed Jupiter and Saturn, Voyager 1 had already surpassed expectations in terms of its longevity and capabilities. Its flybys of Jupiter and Saturn helped scientists uncover even more detailed information about the gas giants and their moons. In particular, Voyager 1's close encounter with Titan, Saturn's largest moon, gave scientists their first clear glimpse of its thick, nitrogen-rich atmosphere, which would later be the subject of intense study by the Cassini-Huygens mission. However, it was Voyager 1's journey into interstellar space that would ultimately define its legacy. In 2012, Voyager 1 became the first human-made object to leave the heliosphere, the protective bubble of charged particles and solar wind that surrounds our solar system. This milestone marked the beginning of a new era in space exploration, as Voyager 1 ventured into the vast, uncharted territory of interstellar space. The region beyond the heliosphere is filled with the interstellar medium, a diffuse mixture of gas, dust, and cosmic radiation. It is an environment that is vastly different from the solar wind that permeates the inner solar system, and scientists were eager to learn more about its properties. As Voyager 1 crossed the boundary of the heliosphere, it sent back data that radically changed our understanding of space. For example, the spacecraft discovered that the interstellar magnetic field is much stronger than scientists had previously thought, a revelation that forced astronomers to reconsider their models of the solar system's outer boundaries. The data from Voyager 1 also revealed that the particles in interstellar space are far more energetic than expected. At the same time, the spacecraft experienced a marked decrease in the intensity of the solar wind, as it transitioned from the influence of our Sun to the more diffuse interstellar medium. These discoveries raised new questions about the nature of interstellar space and our solar system's interaction with the broader galaxy. Voyager 1's twin, Voyager 2, would follow in its footsteps and cross the boundary of the heliosphere in 2018. Voyager 2's instruments had not suffered the same technical malfunctions as those on Voyager 1, and so it was able to send back more detailed data as it passed through the outer layers of the solar system. Like Voyager 1, Voyager 2 found that the magnetic field in interstellar space was much stronger than expected. But it also observed other phenomena, such as an increase in the density of particles as the spacecraft crossed into interstellar space. These findings provided scientists with a more complete picture of the interstellar medium, as Voyager 1 and Voyager 2, traveling in different directions, offered complementary views of this mysterious region of space. One of the most astonishing aspects of the Voyager mission is the longevity of the spacecraft. After more than 4 decades of travel, both Voyager 1 and Voyager 2 continue to function, sending back valuable scientific data from the farthest reaches of space. When the probes were launched, their expected lifespans were measured in years, not decades. Yet the spacecraft's systems, designed to operate for just a few years, have continued to operate far beyond their intended lifespans. This remarkable feat of engineering is a testament to the durability and resilience of human-made technology. As the spacecraft continue their journey, they are providing invaluable data that will shape our understanding of the universe for generations to come. But perhaps the most striking thing about the Voyager mission is the way in which these two spacecraft have become symbols of humanity's unyielding curiosity and determination. Despite the vast distances, the technical challenges, and the unknowns, the Voyager probes have persevered. They are not just machines, but symbols of our desire to explore the cosmos, to understand our place in the universe, and to push the boundaries of what is possible. The discoveries made by Voyager 1 and Voyager 2 have had a profound impact on science, forcing us to rethink our models of the solar system, the interstellar medium, and the very nature of space itself. They have shown us that even in the farthest reaches of the cosmos, there is still much to learn and discover. As Voyager 1 and Voyager 2 continue their journey through interstellar space, they remain silent ambassadors of human ingenuity. They are a reminder that, even in the face of adversity, we have the capacity to overcome obstacles and achieve the extraordinary. The legacy of the Voyager missions will continue to inspire future generations of scientists, engineers, and explorers to push the boundaries of space exploration and seek out the answers to the mysteries of the universe. And while the story of the Voyagers may seem like an unlikely one, a tale of two spacecraft sent out into the void of space with little hope of success, it is, in fact, a story of triumph. It is the story of humanity's unrelenting quest for knowledge, and a testament to the enduring power of curiosity, creativity, and perseverance.